going to give you a little video on how we can use my iMaths for some of the stuff we're going to do on reflections and rotations. Now, normally this would be something that I would teach you in class, and it would be a lot easier for me to show you because we'd be physically present in the classroom. So we're going to kind of work around that by using the stuff that is on the my iMaths, because there's some good visual tools you can see, and I'm going to kind of talk you through a couple of examples, and you can also go on later on and repeat these yourself if you find that will be helpful. So I've just kind of showed you where you can find these. Obviously, when you go onto your portal login, you're going to be able to see that I've assigned you some of these tasks for the online homeworks. But we're going to have a little look at the lessons today. So we're going to look at reflection followed by some rotation. I've just opened new tabs at the top here, and then you're going to try some of the online homeworks, and also you're going to try a couple of these in your books as well. I've just put a couple of things in the bottom corner here. I'm just going to realize it's cropped it off a little bit, so I'm just going to put it in there. Just a couple of things to be aware of, so do read over those as you're going through and keep those in mind for the reflection and rotation. So I'm going to click, obviously I'd click on this lesson here. It would take me onto the online homework, the online lesson, and reflection. Let's talk about reflection first. So reflection is sometimes called mirroring. It's basically where, if you imagine you had this shape here, for example, you stuck a mirror, what would the shape look like in the mirror? Now, previously you've done it where you just have a picture and you have a line and you have to do it. Obviously what we're going to be looking at is doing it on a grid, so with X and Y, positive and negative, like this one here. When you describe a reflection, you need to make sure you give all the information needed, so that if somebody was repeating what you're doing, they could do it without you saying, put this here, put that there. So let's say I had this shape here. First of all, the shape we start with is always called the object, and what you reflect it is called the image, because you image what you see. So here's my object in orange, and if you just grab this little thing on the side, you can scroll it through, okay, you can see that this line here is kind of like where the mirror is, and the shape has been reflected, the blue one here. A couple of things to note: that first of all, object, image, which one's which? So orange is the object, what we started with, blue is the image, and we've got the line of reflection here. This mirror line is a vertical line, okay, and as you can see here, okay, vertical lines are always x equals. We can hopefully see it crosses the x-axis at 1, so this one is x equals 1. So we could say this reflection is reflecting the orange shape in the line x equals 1. Vertical and horizontal tend to be quite straightforward. We'll look at diagonal in a minute. So let's continue on. Okay, let's imagine, oops, being a bit slow. We were looking at some of the other stuff. So as you can see here, talking about this horizontal and vertical, okay, if I was to make a horizontal mirror line, so y equals 3, we can see it crosses the y-axis at 3, or now it's 4, sorry. Okay, we can see that x equals lines are vertical, and anytime we have an x equals or a y equals line, a vertical or horizontal, we need to make sure that we can label them. So just remember, vertical is x, horizontal is y, and where they cross the axis is their equation. So let's look at a couple more examples, okay. Also, we can use the axis, so you can see that, for example, here's a load of pictures. Here's shape P in the bottom right corner. If I was to reflect it in the y-axis, which is obviously the line here, where would it end up? Obviously, if I reflected that shape in that line, you can count the boxes. So from this corner, I can say it goes 1, 2, 3, 4, 5 to the y-axis. So I repeat 1, 2, 3, 4, 5 on the other side, etc., and I can see that M is P in the y-axis. The line x equals -4 would be this line here going through -4, a vertical line. A is here. If I reflected it in this line here, then of course B would be the reflection, because it's the same distance away from the line on the other side. Similarly, y equals -4 would be a horizontal line, and I can see that L is in the bottom right in the 4th quadrant, and if I reflected it in the line y equals -4, which would be here, okay, then it would become shape P. What about if we had to describe what's happened here? So we can see the shape L has gone to shape I. So I'd say, okay, what line is halfway between them? And I can see that the y-axis is exactly halfway between I and L. and it's, of course, that vertical line. From shape K to shape O, K is here, O is here, halfway between them, of course, is somewhere here. It's a horizontal line, so I'm saying it crosses the y-axis at -4. And finally, M to E, M is here, E is here. We look halfway between them, so we count the boxes. We say 1, 2, 3, 4, 5, 6, 7. Notice I'm counting from the corners. Okay, so I'll do that one again. 1, 2, 3, 4, 5, 6. See, I counted wrong the first time. 6 boxes between them, so I say, okay, halfway is 3, so I count up 3 because it has to be in the middle. So I say 1, 2, 3. That's at horizontal line at -2. And that's how we do this. So again, we can see here's the load of objects. If I wanted to first on the x-axis, that means it's going to be in that horizontal x line, so it's going to be flipped like so. Okay, and we can see it looks something like this. If we were to do the shape B in the y-axis, so for example, I could count this pointy corner. At the end, I could say it's 1, 2, 3, 4 boxes from the y-axis. I go 1, 2, 3, 4. It would be -4, -2. And again, I do that for all the corners, counting the distance. X equals 0 is also known as the y-axis, so we can see it looks something like this. And y equals -2, again, horizontal line, something like this. Now, you also might get a diagonal line. This is when things get a little bit more confusing, but not too bad. Y equals x, that means that the y and the x coordinates are the same, so like 1, 1, 2, 2, 3, 3, 4, 4, etc., etc. The line would look from the bottom left to the top right, something like this. Obviously, y equals -x means they're the same number, but one is positive, one is negative, so 1, -1, or -1, 1, and it looks something like this. What does that look like when we do reflections? Well, let's look at the end. Let's say I was going to do shape A in the line y equals x. I'm just going to show you the answer and work backwards. To do this, what we do is we kind of count in diagonal squares. So let's see the bottom right corner of shape A, the kind of pointy bit that looks like that. Okay, this one here you can see is at -2, 2. We can count 1, 2 diagonals, like counting in a perfect diagonal line, and I count 2 diagonals to the other side, and it's here. So it's counting, instead of boxes vertically or horizontally, you're counting diagonally. Similarly, the bottom left corner is at -6, 2. We go 1, 2, 3, 4 diagonals, and then 1, 2, 3, 4 diagonals on the other side. Even if the line is the other way, it's still counting diagonals. So again, top right corner, 1, 2.5. So you have to sometimes use a little half box. And then again, it's half, 1, 2. So it's 2.5, 2.5. It's in the middle. So just make sure that when you draw the new shape, the line splits them exactly in the middle. And that's pretty much it for reflection. Again, feel free to go through all of these again. Let's just talk a little bit about rotation quickly. So here's some rotation. Now, rotation is a bit more complex in terms of its instruction because it consists of 3 different parts. Just remember, first of all, like when a metaphor in your head, think about rotation as like planets rotating around the sun. The sun doesn't move, the planets move around it. Similarly, when we rotate, we have a point in the middle, and then the shape is rotating around that point. So for example, if I started with this pink shape here, this object, okay, first of all, I need to know where's the center, so that's that metaphorical sun, and then that shape is turning around the sun, it's orbiting it, or whatever you want to think, okay. Then I need to know how far is it turning, okay, and then which direction. So for example here, okay, we can see if I rotate that shape, it's gone 90 degrees. 90 is a quarter turn because the whole turn is 360. It's gone clockwise, so that's to the right. If you ever forget, just look at, obviously, I have my watch on, but if you did, you could look at it and notice that the most important thing is the center of rotation. If you look at the distance, you count that little dotted line, it's 3 boxes straight up on the first shape. It's rotated 90 degrees. It's now 3 boxes to the right. But the distance from both is the same. And that's really, really important. You're turning it, you're not moving it. Okay? Now, normally, if we were in class, I would give you tracing paper to do this because that's a much easier way of doing it. So normally I would say, and if you've got tracing paper at home, great. If you've got something really thin like baking paper, if you've got your mum or dad has that in the kitchen, that would be really useful because you can basically use it for the same purpose because it's thin enough that you can see through it. If you were using tracing paper, what I would, and obviously I would have shown you this in class if we were there, is I'm going to rotate this shape 90 degrees clockwise, so to the right, quarter turn around this point here. I would copy the shape onto the tracing paper. See that, well, that little pencil, isn't it? It's fancy. Okay, and then notice that you put your pencil and pin the center of rotation because that one's not moving. And the tracing paper, you can see, is kind of moving around that point. Okay, and I move it around a quarter turn. Okay, and then you can see you've got your new shape. Most important thing here is that the center of rotation, you're moving around that point. Okay, you're not just turning the shape, you're turning it around that fixed point. And that's where students often go wrong. So you put your pencil on the bit of paper and turn it round and then redraw the shape. So it looks something like this. Now, what I quite like on this little tool here is you can see what happens when you move the center of rotation. So let's say instead of the center of rotation being here, it was at 0, 0. And you can see again, it's kind of 2 along, 1 up, 1 along, 2 up, 2 down, sorry. So the distance between them is the same. The further away the center of rotation is, okay, the further apart the two shapes are, the closer the center of rotation is, the closer the shapes are. Oh, it's frozen. Are we back? Ooh, I've frozen. That's annoying, isn't it? Are you going to come back? Yeah, it's back. Hooray. It seems like it's alive again. So just remember, okay, go back to the beginning, copy the shape if you have it, pin the point, move around, make sure you're using the same distance for these. Okay, if you're describing it, so it says describe the rotation, remember that you need to know the 3 things we talked about at the beginning. Where's the center? How far are you turning? And in which direction? Okay, I always think of a metaphor as if you were on the phone to somebody who couldn't see your screen, they couldn't see what you were doing, and you were going to describe it to them, you need to give them those 3 bits of information so they can do exactly the same thing as you. So you need the center, direction, and what we call magnitude, how many degrees. So here, for example, going from E to K. Okay, first of all, we can see it's rotating a quarter turn, so it's 90 degrees. Okay, but we'd need more information than that. We'd also need to say, well, where is it rotating through? Oh, it's not going to give us that information. That's being a bit funny today. We'll kind of go through. So again, A, it says go 90 degrees anti-clockwise around 2, 1. So again, we'd mark that center point, we'd have put our pencil in, and we'd have turned the paper around it, and you can see the distance is the same. Similarly, B, 180 degrees. It doesn't give a direction for 180 degrees because a half turn is the same both ways. So that's the only time you don't need to say clockwise or anti-clockwise. Again, center of rotation is 2 squares away from the shape. C, again, center of rotation, it's the same distance, 2 squares, 2 squares. Clockwise, 90 degrees, there's the center of rotation. And finally, we've got one here that's like upside down, 1 square, same distance. Okay, finally, anti-clockwise. Yeah, this is something you may see in some of the questions. They sometimes call it a positive rotation. Okay, it basically is exactly the same thing, going the opposite direction. Just remember, again, center of rotation, equal distance, moving around that point. Okay, so if you ever see that plus 90, that just means anti-clockwise. Okay, and then clockwise is the same thing, but negative. So just in case you see that, that's what that looks like. So that's a basic little intro to rotation and reflection. This is one of those things that's best actually done as opposed to just talking about it. Isn't that right, Meredith? Yeah, she's asleep. So have a go at these. Feel free to use these little My Maths lessons to help you. Sorry that I can't show you in person, and it's obviously much easier to help you when I show you in person. And just remember, keep those things there in mind. Reflection, x equals, y equals minus x, and y equals x. And rotation, you need a center, direction, and how far. The center is the most important thing. That's where you put your pencil on and everything turns around that. Okay, I'm just going to show you one more time on the graphic. Just remember, okay, sorry, the next one. Okay, just remember, copy the shape, and it's pin with the pencil and move around like so. Okay, can't stress that enough. And if you have baking paper, that would be really useful, because you can, if you hold it really tight to the paper, you can probably use it as not as good as tracing paper, but in these at-home learning times, it's probably the best we can do. So have a go at these and see how they go, and let me know if you have any problems. Bye, Meredith. You gonna say bye? No. Okay.